My dear students, in this video, I'm going to discuss a few points about the newly published the SOFA 2 score, that is the second version of the SOFA score, which was published in December in JAMA, and how it is different from the original SOFA score that we calculate in the ICU, and what differences it can make in our clinical practice as well as in the research. So, as you all know, that the SOFA score, or as we call it, the sequential organ failure assessment score, is a bedside ICU tool which is used to quantify the degree of acute organ dysfunction and to predict mortality, especially in patients with suspected or confirmed sepsis. And as an extension of this SOFA score, the Surviving Sepsis Campaign Guidelines in 2016 had come out with the Q-SOFA to make it even more simple. Now, if we go by the history and if we go into its origin, although it was demonstrated strong association with morbidity and mortality in critically ill patients, we look that it was not originally intended as a prognostic score. It was just for diagnostic score. It evaluates 6 organ systems, we all know that, each with a score ranging from 0 to 4, and therefore it has a maximum score of 24. And as per the Surviving Sepsis campaign, also an acute rise of more than equal to 2 points identifies life-threatening illness and defines sepsis. Now, this has what we all have been using so far, or this knowledge was applied during assessment of patients when SOFA score was calculated. Now, why was there a need for an update? This need arose because of substantial changes in the ICU practices, the emergence of new organ support technologies, and the increasing need for equitable applicability across resource rich and resource constrained settings. So some of these things were developing so fast since the past decade, and our original SOFA, which was revised in 1996, could not keep pace with these changing needs and therefore remained unmet on several of these aspects. So that was the one reason. And then there was growing integration of electronic health records and AI-driven decision support systems, which all know that has significantly risen in the last 3 to 5 years. So that requires updated and digitally compatible scoring tools to facilitate automated calculation and real-time interpretation. So this was also another felt necessity for which an updated version of SOFA was considered to be useful. Was expected to be useful, and therefore this development of validation and SOFA score came out in JAMA in 2025 16 December. And if we look into the publication, we find that this was performed on a data which was collected from adult patients in 1319 intensive care units across 9 countries, which was a huge data set spanning across Australia, Brazil, France, Italy, Japan, Nepal, New Zealand, and United States, although it doesn't mention India. I think data was not collected, and therefore Nepal data was there, which somehow represents the South Asian population. And this was between 2014 to 2023. 4 representative multi-center cohorts containing the data were used for data-driven score development and internal validation. And external validation was also performed using the 6 cohorts. So, the main outcome and measures were the content validity for organ dysfunction identified through modified Delphi process, which was reflected by predictive validity using the area under ROC of the score measured on the first day of the ICU. So, high score indicated worse organ dysfunction. Now, this is the flow in which it was done. The stages 1 to 5 was the first and second modified Delphi, which looked into the rationale and development of the SOFA 2 proposal for 8 organ systems, including brain, respiratory, cardiovascular, liver, kidney, hemostasis, immune, and gastrointestinal. So you note that this immune and gastrointestinal were the additions. In the stage 6, there was internal validation of 4 representative cohorts, represent around 2.1 million ICU admissions. So there was both data-driven evaluation of thresholds and derivation of proposal so far to score options. And then it went into the stage 7, which was the third modified Delphi, where SOFA 2 scored approval by a Delphi vote, with where it was found that the immune and gastrointestinal system were deemed unsuitable, so they were eliminated. In stage 8, there was the external validation, where SOFA 2 and SOFA 1 scores derived in the 4 internal validation cohorts and an additional 6 cohorts with all this 1.2 million ICU admissions, which is mentioned in the stage 6. They were combined. And then the SOFA 1 and SOFA 2 distribution, along with their predictability, was determined. Now, this is in very brief the flow chart of how this was done. But the most important is what are the key differences in the scores in terms of the organ system at the score, and how it can affect our clinical practice. Now, in brain, according to the original SOFA, where only the GCS total score is taken into consideration, in the revised SOFA 2 score, the GSS is retained, no doubt, but explicit rules are added for sedated patients, like motor score if unaccessible, and for delirium treated with pharmacological agents. So that makes it more closer to a reality. In the respiratory system, the PF as a measure of respiratory dysfunction was used in the original SOFA, with higher levels only scored for mechanically ventilated patients, whereas in SOFA 2, either PF or SF, that is SpO2 by FiO2, is there, and inclusion of NIV, HFNO, and ECMO. So clear operational thresholds for each modality and level of support has been guaranteed. So this is again one advancement over the original SOFA of 1996. In the cardiovascular system, the MAP threshold, catecholamine based grading of higher scores, that is dopamine, dobutamine, epinephrine, or norepinephrine, was used for scoring, whereas in the 25 edition, standardized dose equivalents, including vasopressin, angiotensin 2, etc., mechanical circulatory support, explicit rules for titration, and the ceiling of therapy scenarios, they were included. So that again makes it more refined and more close to the real time situation. Next, coming to the renal component of the renal system, the serum creatinine or urine output of less than 500 ml per day or less than 200 ml per day, RRT, was considered as grade 4 in the original SOFA, where serum creatinine and urine output was maintained. Explicit criteria for acute or chronic kidney disease, scoring options when RRT is unavailable, and the distinction of renal versus non-renal RRT. This finds place in the SOFA 2 edition, and of course that makes it more scientific and logical. In the coagulation system, the platelet counts with varying thresholds were incorporated in original SOFA of 1996, but here in 2025, the platelet counts are retained with refined definitions for counts less than 20,000 and considerations for confounders, and standardized sampling and timing guidance have been added. In liver, serum bilirubin as a marker of liver dysfunction with increasing thresholds was used in the SOFA score of 1996, but here in the current SOFA 2 version, the serum bilirubin is retained with threshold clarification, but additional rules for direct versus total bilirubin and for patients with chronic hyperbilirubinemia have been added. So that also makes things more refined. The additional issues are the gastrointestinal immune domains are not included because lack of predictive and content validity. The scale 0 to 4 is retained. Explicit rules for persistence, missing data, and chronic dysfunction has been added. It is designed for EHR integration and automated computation, so supports interoperability and application across different resource settings. So these are some of the additional issues which have been incorporated in the SOFA 2 version. So what are the practical implications for critical care? Clear instructions are included for patients with chronic organ dysfunction like RRT or long-term mechanical ventilation, distinguishing baseline abnormalities from acute deterioration. The new framework also defines standardized approaches for handling missing data and for cases where a ceiling of treatment precludes advanced organ support. And SOFA 2 version also facilitates integration into electronic health records and automated data systems, which enables real time calculation, reduces human error, and supports continuous monitoring of organ dysfunction both at the bedside and across multicenter registries. So, this digital compatibility supports more timely clinical decision making and enhances consistency in patient monitoring across teams and institutions. What are the implications for research? By aligning research definitions with contemporary clinical realities, this advanced the SOFA 2 version creates a common language that not only enhances scientific rigor but also facilitates its translation into bedside decision making. And this transition of SOFA 2 will affect research frameworks that rely on the original score for sepsis, like sepsis 3 trial eligibility benchmarking. So, updated variables like the SF ratio, HFNO, NIV, vasopressin, angiotensin, and ECMO reflect contemporary practice but may challenge the established datasets and the risk models. So, what is it means is that we might have to redo or revalidate our previous work with against this new SOFA 2 score. And further research should focus on trajectory based endpoints and integration of frailty and comorbidity indices to enhance calibration and clinical relevance in heterogeneous ICU populations. So, in these heterogeneous ICU populations, probably it becomes more valid and more useful because it fine tunes those points which were missing in SOFA, and therefore the recording, the although the score remains the same, but the score can be appropriately labeled score. So, the guidance for implementation, the SOFA 2 score provides a structured framework that can be seamlessly incorporated into both bedside assessment and research workflows. For clinicians, its standardized definitions and explicit scoring rules allow for reliable daily evaluation of organ dysfunction, even across teams with varying levels of experience, because that varying levels of experiences can be nullified by the precision which this scoring system has attributed the scores. And for researchers, the scores, harmonized variables, and thresholds facilitate reproducible data collection and uniform interpretation across studies, enabling more accurate comparisons between cohorts and interventions. So, this requires a practice. So, probably as we become used to it, as we practice this scoring system, we will be able to understand these in a much better way. To further support real world adoption, the user oriented materials such as operation manual and digital calculators, they are also under development to facilitate consistent and efficient application in both clinical and research settings. And that would minimize the inter-observer variability or inter-observer variability in attribution of score significantly, which is going to improve the validity of the score. The limitations and futures perspectives, it still requires prospective validation to confirm reproducibility in real world workflows across varied healthcare systems and disease profiles, just because it is too new. The exclusion of gastrointestinal and immune dysfunction, despite being frequently evaluated by intensivists, it reflects the current limitation in available datasets and operational feasibility at the bedside. SOFA 2 is not intended as a static endpoint, but as a foundation for a dynamic, data informed framework for organ dysfunction assessment. So, again, the trend will be more important rather than the value of the individual score. And further iterations should incorporate emerging technologies, enhance adaptability in low resource settings, and explore integration of complementary constructs such as frailty, comorbidities, subphenotypes, and biomarkers, because these are being added into the data sets to a large extent. So these need to be evaluated, they need to be adjusted within the scoring system too. So the final take-home message would be that SOFA 2 preserves the conceptual simplicity and descriptive purpose of the original score while aligning organ dysfunction assessment with contemporary intensive care practices that are the that are considered as the best practices, of course. And its standardized definitions enhance clinical and research consistency, promote interprofessional communication, and enable reliable monitoring across diverse care settings. So the chances of difference between the individuals while recording the score has been grossly minimized. And the updated structure supports equitable application in both high and low resource environments, and then that facilitates integration into the digital health ecosystems to give it a much bigger global acceptance. Thank you very much.